Hello, and welcome to Google I/O 2012. Today I'm going to be talking about building web applications that use Google APIs and the JavaScript client for Google APIs. My name is Brendan O'Brien. I'm a software engineer on Google+, and I also maintain the JavaScript client. As the title implies, we're going to be talking mainly about the client, what it can do, how you do that, and how you use it to consume Google's APIs. So a little bit about our APIs. We provide many RESTful APIs for most of our products and services. This includes Google+, Calendar, Analytics, and over 35 more discovery-based APIs. We even announced a few here at Google I/O. Hopefully you've seen some of those sessions. Requests are typically made to www.googleapis.com, which is Google's APIs front end. So I have an example here. Since it is a RESTful API, I can take this URL and just paste it into my browser here. So what this one is going to do, let me go back real quick, is you can see in the URL here that URL shortener /v1. This is going to go to URL shortener API at version 1 and take this shortened URL and give us back the long full URL for it. So if I paste that in, we should get some data back. And here we are. We have a JSON blob, and we can see one of the fields is long URL, www.google.com. So that's what the short URL translates to. And there are some other fields in here that might be useful for you as well. So we also provided several API clients to make accessing the Google APIs easier for you. We have a total of 9 clients right now. Besides just JavaScript, there's Java, Objective-C, Python, and many more. And I have a link here if you're curious later to see all the clients that we currently have. So before, if you wanted to consume Google APIs, you had to do it from your web server using one of the server-side scripting languages, Java, Python, something like that. So in order to make API calls, your code in the browser would have to call back to your web server. Your web server makes a call to the Google APIs server to get a response back, and then it has to pass that response back to the browser. So a lot of logic must exist on your web server to make this possible. Well, with the JavaScript client, you can make these calls directly from the browser. This makes your web server a bit simpler, and also just makes it so that you can make these direct calls a bit quicker. So I'm going to do a quick demo using the JavaScript client, and I have a little snippet of code here. This is basically all the code that exists in the demo that I'm about to show you. This is all that's needed to load an API and then make calls to it and get a response back. So here is this demo. Again, I'm going to use the URL shortener API as an example, and I'm going to take a short URL and expand it out into a long URL. Now you'll see that I pre-populated this field here with the same short URL that we had before, so if we expand it, as we expect, we see that this short URL expands to www.google.com. And like I said, the code you saw on the previous page is all the code that's running on this page besides HTML markup and the little things to make it slightly pretty. So now that we've seen a demo and seen what it can do, let's talk in a little bit more detail about what it provides and what it can do. First, a note on compatibility. We support 4 major modern browsers, including Chrome, Firefox, Internet Explorer, and Safari. We also have built-in support in the JavaScript client for the OAuth 2.0 authorization protocol, so that your applications can be authorized to retrieve sensitive or protected user data on their behalf. And we also support many APIs, as I mentioned earlier. I'm just going to click through really quickly to the Google APIs Explorer. This is where you can see a list of all the APIs we have and what versions they're on. And it also allows you to see what methods are available on each API. What's also really cool is you can run these methods directly from the Google APIs Explorer and play around with them before actually implementing any code in your project. So it's very useful. And I'll be doing a little bit more with the APIs Explorer later. And also, if you are interested and you attend the code lab, we'll be doing a lot more work in the Explorer as well. So let's just have a quick look at it. So we can see the list of APIs here. We can scroll down and see the various versions. There's a little description on the right of the API and exactly what it does. So here's URL shortener down here at the bottom, the one we've been using. If I click through, it mentions, or it has all the methods that are available on URL shortener, what their names are, and again, a quick little description. And you can also see at the top, there's a link to the full documentation for this API, and that will tell you in detail what the calls are that can be made, how to make them, what the response is going to look like, etc. And so we'll come back to this later when I actually, excuse me, demonstrate exactly how you can make calls from the API's Explorer to learn about these calls. Okay, so you're probably wondering, well, what do I get by using the JS client? Well, the first thing is we have a method that allows you to make these RESTful requests. All of our APIs are based on the REST protocol, which is also the basis for HTTP. URLs typically identify resources, and then you specify the HTTP verb, such as post or put or get, that is going to do an operation on these resources. So I have another snippet of code here that shows how to make a REST request in the JavaScript client. The method for that is gappy.client.request. All the methods are on the gappy.client namespace, or for our authorization method, the gappy.auth namespace. So this is the same example I've been using so far. This is the URL shortener API, and we can see in the path we saw before I mentioned, or I list first the API I want, URL shortener, and then the version of it that I'm trying to access. And then as I mentioned, there's a resource at the end. URL is the resource we're trying to access here. And then we pass in a few params to let the API know exactly what we want to do. Since we pass in a short URL, it knows that we want to get back information about this short URL. In particular, what does it expand to? What's the long URL? So when you call gappy.client.request, you get back a REST request object. It hasn't actually made the call yet. In order to make the call, you call execute on the REST request. It's the only method defined on it. And it takes one parameter, a callback function. And I'll be talking about that in a little more detail later as well. So the other way you can make requests, or another request format that we support, is JSON-RPC. When you make the request, it's encapsulated as JSON data in a post body, and the response is always JSON, as the name implies. So again, I have an example up here of the same URL shortener that we've been using. And here you can see the signature looks a little different. It says gappy.client.urlshortener.url.get. So if you remember from the API's Explorer, that's the exact name of the method that we're trying to execute. And we can see we can just call it directly, pass in our parameters that we're interested about, and again, we get back a request object. This is now an RPC request object. But it's very similar to REST request. It has one method on it, execute. You pass in a callback, and when the function returns, you can play around with the response. So I also said that we have a built-in mechanism that supports OAuth 2.0 authorization and authentication. Essentially what you do is you create a client ID, and we'll be going over that later as well, which identifies your application. And you also gather a set of scopes that you'd like to have access to. So if you've ever installed an Android application, for example, it tells you what this application wants to access. You know, does it want to see your location or maybe read your profile? So these are the kind of things that scopes identify to the OAuth server that you want to access for this user. So here in this example, I have just a random client ID. And then I have one scope that I'm interested in here. And this says, this is the calendar scope. So this will ask the user, this application would like to access your calendar, possibly read and also possibly manipulate. Is that OK? And we'll be seeing an example of that later. So the interface to do OAuth 2.0 authentication is gappy.auth.authorize. You pass in the client ID I mentioned, the scopes, and you can request multiple scopes if you need access to multiple APIs. And then we have this immediate value, which I'll be going over a little bit more later. Now that's all contained in one object, so that's the first parameter. The second parameter is another callback method, and this will be passed the result of authentication. And if it's successful, you can continue on and use your application. If not, you'll need to handle the error somehow. So now we know what the Google API's JavaScript client can do, and I'm sure you're curious, how do I do that? I've shown you some brief examples, but now I'm going to go into a little bit more detail about how exactly we can do that and how that works. So two things I want to go over before we begin. The first is the API's console. And this is where you create an API key and a client ID, and both are used to identify your application when making requests. And again, we'll be talking about those in more detail when I go over authorization. And this is also where you activate the APIs that you're interested in. So you saw a long list of APIs in the APIs Explorer. Well, you turn on the various APIs that your application is going to need access to. And you can do more in the APIs console to manage your product or in your project. You can change the quota for the APIs. They'll have a default amount of quota that they're allowed to access every day. But you can request more if you need more. If your applications become very popular, then you might need to do that. This is also where you manage billings. A few of our APIs are paid APIs, and you have to set up billing there. And you can do team management as well to add more members to your project so that they can go in and also change these settings. So I showed you the APIs Explorer briefly. This is, as I mentioned, a great starting point for documentation. First, you can just go through the list of all the methods that are available on the API and get a brief overview of each. And as you saw, there was a link to the full documentation so you can find out just everything you want to know about this particular API. You can try the API calls out from the Explorer as well, and we're going to do that right now. So here's that short URL again. I hope you're noticing a theme. So we come back into the APIs Explorer, and I want to find the URL shortener API. So here are all those methods again, and the description of the first one says expands a short URL or gets creation time in analytics. Well, great, that's exactly what we're looking for. I want to see what this short URL expands to. So I click into that, and it gives me this form where I can fill in the parameters for this particular method and let it go. As you can see, the bold red ones are required. Let's get that up a little bit. So I'm going to paste in that value here that we had before for short URL and execute this method. Now if we scroll down, the APIs Explorer shows us the request that was made. We saw this URL in the beginning of the presentation. And then it shows the response as well. And this is the same response we saw earlier, a JSON response where long URL has the value that we're interested in. OK, so now that we've done that, we're ready to use the JS client. Well, to load it, the URL is here. It's https apis.google.com/js/client.js. Now, the way the JS client loads, it loads asynchronously in two phases. We do this, obviously, so that it doesn't block your page and make performance terrible while you're waiting for the page to load. But this also means you need to know when the JS client is actually loaded and is ready to use. So to do that, we have added this onload parameter, URL parameter, that you add to the URL, and it specifies a global function, global JavaScript function, that it should execute when the JS client is ready to use. So let me just highlight those two things here. You can see the URL for the API and the script source, I'm sorry, for the JS client and the script source with this onload parameter, and it's pointing to this global init function, which is defined above. And once the init executes, we know that the JS client has loaded, and we can run off and start consuming APIs. So the first of the two ways you can make requests in the JavaScript client is by making a REST request. When you go into the documentation, the full documentation for each API, they tend to describe the APIs in terms of REST. So what are the URLs that you need to construct to access various resources? What are the methods you need to make? The HTTP methods you need to use to manipulate these resources. So here again is the REST request method, as we just call it gappy.client.request. And it takes one argument, which is what we call a bag of arguments. It's just an object with key value pairs of a couple required, well, one required, and several optional parameters. So let's just go through those very quickly. The first is the path to which you're making this request that identifies the resource that you're trying to get or manipulate. Earlier we saw that for the URL shortener, it was URL shortener /v1/URL. So that last part /URL is the resource that we're interested in. Now you need that whole path in the Gappy client request, and we'll see that in a second. The next parameter is params. These are URL parameters that will be serialized and encoded and added to the path when this request is made. When going through the documentation, some of the APIs have URL parameters that you can use to control how the method is executed or maybe how the response comes back. And so this is where you would add those parameters. Next we have method, which is the HTTP method. This is again optional. It defaults to a GET, but you can do, again, many APIs support posts and deletes and inserts in particular for deleting and inserting more resources. And then next we have headers. This is a key value pairing, again, of headers, and it's optional, that you can send along with your request. These are, again, just HTTP headers. And some of the APIs have some headers that you can set, again, to control or manipulate the request as it's being made. Next, we have a body, the HTTP body. Particularly when doing inserts and making REST requests, you'll serialize a JSON object into the body, and that will get sent to the API. And finally, we have callback. This is, again, optional, but it's a callback function that will be executed when the request returns. Now, you don't have to provide this. If you do, the request is executed immediately because it has a callback. If not, you get the REST request object back that we saw earlier, and then you can call execute on that, and that's where you would pass in the callback function. So here's an example. I've switched APIs now to the calendar API because it works very well for this example. So we see in the path that I want to specify the API and version that I'm interested in, calendar, v3, and the documentation will mention this. And then I want to access me as a user. So I put in users/me, and in the documentation, me is a special keyword to let you know that it wants to access the currently logged in users, so the users of your applications, their calendars. And then the last is calendar list. I want to list all the calendars that this user has. So then I have the method as a post, because what I want to do for this request is insert a new calendar. So I'm posting to this resource to insert a new value. Next, I set one header value, which is content type application JSON, to let the API server know that I'm sending JSON data along with this request. Now, this is actually the default. It's always included, but I've included it here for illustration of the headers parameter. Next, we're passing along a body. So as I mentioned, we're inserting a new calendar here, and this is how the API expects the new calendar to be inserted. You pass in a calendar resource, which the documentation describes, to create this new calendar. So I've included one parameter that's required, the ID, and that's just my demo email address here. And then I've also included an optional parameter value, the selected true. And this will mean when you look at the calendar the calendar UI, that this calendar will be selected by default, and you'll see your events in the calendar UI. And then I pass in a callback so that this request will execute immediately. And when it returns, it will execute this function. So let's talk a little bit about that callback. So the callback takes two parameters. The first is called JSON response, and this is the response from the response body parsed as JSON. This will actually be the Boolean value false if the response is not valid JSON or if it's just not JSON at all. This could be the case for a few APIs, but it's kind of rare that you'll not have a JSON response. If you don't, we also provide raw response, which is the full HTTP response as a string. So this is actually JSON, even though it is a string. You can parse it out into an object that contains the body response, the headers, which is another key value pairing, an object that were sent as response headers, the status of the request, and then the status text as well. So if you're interested in anything besides the response in the body, the headers, the status, or the status text, you would find that in raw response. So the other request format that we can use is JSON-RPC. And there's actually several ways we can make a JSON-RPC request using the JS client. The first is by just directly creating one of these objects. So we do that with gappy.client.rpc request. And the format, as you see here, is it takes 3 arguments. The first is the method you want to execute. The second is the API version of the API that you're trying to access. And then the parameters for this actual request are passed in as the third argument here. So I have a quick example. This request is going to search the Google Plus profiles. So that method is plus.people.search. You can find that again in the API's Explorer, the method name, and what the current version is. In this case, it's v1. And then we pass in a JSON object, or an object, key value pairing, of the parameters that this method expects. So it only has one required parameter, and that's the query you want to make. And so I'm going to look for every profile on Google Plus where the person's name includes Lewis. So that returns back our RPC request object to me, and then I can execute that and pass in a callback. So you may remember from before, I didn't use that RPC request method when I introduced our JSON-RPC. I called a method directly on the gappy.client namespace. Well, this is how you set that up. We have a gappy.client.register method, which registers this method that we're interested in, so that we don't have to always put in the method name that we want, and particularly the API version that we're interested in. So when I do this call here, gappy client register plus.people.search, and pass in the API version, it's going to register this method, and remember that the version that we're interested in for this method is v1. So that registers in the gappy client namespace. We do this to avoid polluting the global namespace and keep it as tight as possible. And the way we register it is by separating on the dots in the method name and turning that into a namespace and function name. So plus.people.search becomes gappy.client.plus.people.search. And then this is a method. So when you execute this method, you pass in the params for the RPC request that you're trying to make. And again, it returns to you an RPC request object. So in the example down here at the bottom, let me just highlight that real quick. This is where we call the method. I pass in the same query that I was interested in before. I want to find everybody named Lewis. And I get a request object back. And then I can execute that request object and pass in a callback. So now with JSON-RPC, you can load one in particular API, the entire API, all at once, so that you don't have to, for example, register every single one of the methods. We looked at URL shortener earlier, and there were 3 methods. Well, some have quite a few more than that. They may have 3 dozen, for example. And you don't want to have to put in your code a line gappy.client.register for each one of those methods if you're going to be using them most of the time. So the JS client provides a convenient method called load, gappy.client.load, which will load the entire API surface, register all the methods, and when we do that again, it will remember the version that we're interested in. And so this is a nice convenience method that will save us some time and some coding in our code. So the way this works is you pass in the name of the API you're interested in. This is typically the first part of the full method description. So in plus.people.search, the first portion was plus, that's the API name. And then we pass in the version we're interested in, v1 in this case. And then it also takes as a third argument a callback to let us know when that API has loaded, all the methods are registered, and we can start making requests, registered method requests on that API. So this one, for example, registers all the Google Plus API methods. So we saw how to make a JSON-RPC request. We saw a couple methods of making a JSON-RPC request. And in all of them, we pass in a callback to this execute method. So this callback is very similar to the REST callback, in which we get two parameters passed to this callback. The first is JSON response. Again, this extracts the returned value from the HTTP request, parses it at JSON, and then passes it as this parameter. And again, this will be false if the response is not valid JSON or not JSON at all. But of course, since we're working with JSON-RPC, that is going to be extremely rare if it ever happens at all. But just in case, we include the raw response, which is the entire RPC response as a string. It's always present, but you may not always be interested in it. So again, if it's not JSON, you can do your own custom parsing on this. But again, I don't think that'll be a very common use case. So one cool thing about JSON-RPC requests is we have built-in support for making batch requests. Say you have a snippet in your code that makes many requests in order. And for each one of those, it's going to be making an HTTP round trip. And these are HTTPS round trips. All of our requests are made on SSL. So they can be quite costly. If you're making many of them, it would be nice if you could make multiple requests with just one HTTP round trip. Well, this is what batching allows you to do. All requests are sent off and executed in parallel, and then they all come back at the same time with their various responses. So let's go through quickly how you use the JSON-RPC batching. Well, the first step up at the top is create a new batch. And that method is GAPI client new RPC batch. And this gives you back a batch object. We can then add requests to the batch object. And when we're done adding requests, we can execute it and go and get our responses back. So the next two segments we see here is the add method, batch.add. Well, let me show you first in the code. I've created two RPC requests just for illustration. One is a direct creation where I call RPC request and pass in the method and the API name that I'm interested in. And this one's going to search for all Google Plus profiles where the person's name contains Larry. And then I create another request from the registered plus.people.search method. And you can see in this case it's a little bit simpler. All I have to pass in now is the query parameters that I'm interested. And so then this request is going to search for all people on Google Plus named Sergey. So now I want to add both these requests to my batch and then execute the batch. Well, in the batch.add, the first parameter, the first argument to this method, it takes two, is required, and it's the request you want to make. Makes sense. The second argument is another one of these bag of args with some optional parameters in it. The first is going to be the ID for this request. So obviously, you're making multiple batched requests here. When it returns, it may not necessarily be in the same order that you added them to the batch. It just depends on when those requests finish on the back end. So if you want to be able to access the response from this entire batch, you'll need an ID for that. So for the Larry request, I've added an ID, we're just going to call it Larry. And so that will identify my response. I've also passed in a callback. And I define this callback up above. Right now it's just an empty function, but you can see it's got the same callback signature that we've seen before. For the second request, I add it and I don't use any of those optional parameters. Now, if you're interested in the response for a batch, you're going to want one of the two, ID or callback. You'll either want the ID to extract the response from your batch response, or the callback, because this individual callback will be called with just the response for this batch operation, not for the entire thing. So once I've added two requests to my batch, I define a batch callback. Again, this is just an empty function for illustration purposes, but you can see that the signature is similar to what we've seen before. We'll go over that in detail in a second. And then I execute that batch and pass in the batch callback. So a little bit about these callbacks. As I mentioned, there are callbacks for individual responses. You saw we added one for the Larry request, but not for the Sergey request. And then we also, when we executed the overall batch operation, we sent in another callback method. So how do these get executed when the response returns? Well, individual batch callbacks are all executed first. You're not guaranteed the order, but you will be guaranteed that those will execute first. And then when all those are done, the overall batch callback is executed. So what gets passed to these callbacks when the response has returned? Well, again, it's very similar to what we've seen before for JSON-RPC requests. The first is a JSON response. This is the response parsed as JSON, so you get a JavaScript object back. For individual callbacks, this is the response, as I said, just for that particular method. So the Larry callback we saw will be executed and only receive the response from the search for people named Larry. It will not see the response for Sergey in this JSON response. For batch callbacks, this is all of the responses, and it's a map of the batch ID to the particular response for that batch operation. And then the second parameter is the batch response, which is the same overall ID to response mapping, but this is just a string. What's nice about this is it always includes the full batch response for both individual callbacks and for the overall callback. So if in one of your individual callbacks, you're going to need to access data from another batch operation you've made, you can either look in this batch response, or you can also use the overall batch callback, as that will receive the ID to response mapping as well, but that time in the JSON response parameter. So I have an example down here from our previous slide, those requests we made in the batch. We get a response back, which is just an ID to response pairing. The first ID is Larry, since we specified what ID we want that response to be identified with. And then the second one is just a random string that the JS client automatically assigned for you so that it has a unique ID identified with it. And then each one of these has the individual responses, the search results for Larry and the search results for Sergey. Okay, so now I'm going to diverge just a little bit. We saw the two sort of request formats that you can use with the JS client. One is the RESTful style. The other is JSON-RPC. Well, we also provide an option for using a different transport for making these requests. So astute observers will notice that we're making calls to www.googleapis.com from your domain. Your application is running on a different domain. We're not going to let you run on googleapis.com. Well, you can't make XML HTTP requests to a different domain. It's not allowed by browsers. Well, the JS client gets around this in a somewhat clever way, but it's also a little bit bulky. And it's proprietary as well. But there's a new transport out there called CORS, which stands for Cross-Origin Resources Sharing. So if the server that is accepting XML HTTP requests supports CORS and says CORS will be allowed for these requests, then you can make a CORS request. And so we've implemented this on googleapis.com. So you can make direct XHRs to Google APIs and access our APIs. So these are constructed similar to REST requests because we're just making HTTP requests, and as you may know, that those are based on the REST protocol. So I have a snippet here, and what's cool about this snippet that I've included is you can take all this code, copy it into a page, make a request, and it will work. Well, with one caveat. I've provided a dummy API key here. But if you change that and put in your own API key, this would work just fine. So we can see that in this example that some of the translations that we need to make. So when you open an XHR, the first parameter is the HTTP method you want to make. So that was provided in GAPI client request. Here's where you put it here. And then the second parameter is where you want to make the requests to. So you can see I have to include a bit more in this example. I have to include the domain I want, www.googleapis.com. And now there's this new parameter key with this sort of encrypted value here. And what the heck is that? Well, when making requests, you must identify your application, either using an API key or a client ID. We'll get back to this again a little bit more when we talk about authentication. Normally, the JS client, you set the API key once, it remembers it, and for every request, this key is sent. Well, if you're making a CORS request, you're not using the JS client, and so you need to remember to add that. The same is true for this request header here, content type, application JSON. I included that in the REST example earlier for illustration purposes and mentioned that the JS client will handle this for you. Well, if you're making direct requests through CORS, you need to remember to set this as well. The callback is set by sending a function to the onload parameter and getting the response from the XHR response text. And we send the payload in the body through the xhr.send. So in this example, I'm actually inserting a long URL to try to get back the shortened version for it. So when I send the request, I pass in long URL google.com. So why did I mention this? Well, first, we just think CORS is pretty cool. It's a native transport, which means you don't need to use, as I mentioned, our sort of proprietary cross-domain handling method, which means it allows for faster requests overall. It's also standards compliant, non-proprietary, and it's native to most major modern browsers. So I encourage you, if you're interested, to try out CORS requests, but with a couple caveats. One is that browser support is currently not quite as expansive as the JS client. So the JS client will handle pretty much any major modern browser that your users are using, but CORS is not quite there yet. Also, since it's not currently implemented in the JS client, if you stop using the JS client, you'll miss future updates to the JS client. So that's why I mentioned it to use maybe as an experimental basis, or perhaps you know that your users are only using compliant browsers, and so you just want to use CORS instead. Well, that's a great use case for that. So I've included a useful link here to caniuse.com, which will tell you which browsers and which versions currently support this. So let's summarize the two request formats that I've mentioned here. The one is JSON-RPC, and the other is REST. So which allows you to set and read HTTP method headers and bodies? Well, the REST does, as we saw. They had those various parameters that you can pass in. But JSON-RPC does not. It only allows you to pass the parameters that the API expects. What about batching? Well, JSON-RPC has built-in batching. We saw that earlier. It was pretty easy to do. There's just a few method calls you need to make to get that to work. REST also supports batching, but it's quite a bit more tricky to do, and it's not built into the JS client currently, so you'll have to do it by hand, and it's really kind of messy. I definitely suggest right now using JSON-RPC if you want to do batching. And we also saw that with JSON-RPC, we can auto-load full APIs, register all those methods, and then make these really simple requests on them by just passing in the query parameters that the API expects. Whereas with REST, you pretty much need to construct every single request manually by hand. We also have two transports. One is built into the JS client. We call that XD3. And the other is CORS, as I mentioned. Well, if you use the JS client, then your requests are automatically formatted. So I mentioned before that CORS requests generally translate well to REST requests. Well, you can also make a JSON-RPC request using CORS if you get the format right. Well, the JS client handles the format for you, so you don't have to worry about that. And it can be maybe a little bit tricky. So CORS doesn't allow you to do that, at least currently. The JS client is fully cross-browser compatible. We saw all the clients that it supports. That'll cover most modern browsers, major browsers. Whereas CORS only has partial currently. However, CORS is native to the browsers that do support it, whereas the JS client obviously is not. You need to download that into your application. JS client has built-in auth, however, and allows us to make these OAuth 2.0 authentication and authorization, whereas CORS does not. Those endpoints don't support CORS currently, so you'll still need to use the JS client if you want to do authorization. Well, let's talk about authorization. This is the last major piece of the JS client that it provides. So just a very quick OAuth 2.0 overview. This is probably a review for most of you. It's in the webinar, if you've seen the webinar, and there's also some talks at Google I/O that talk about OAuth. But just a quick overview, I found a great quote for this. OAuth is a security protocol that enables users to grant third-party access to their web resources without sharing their password. So normally, if we did not have OAuth, the user would have to give your application their username and password so that you could sign into Google for them and make requests to the Google API servers. Well, with OAuth, that's no longer necessary. Instead, the user logs in directly to this third party, in this case, the Google API server, and gets back an access token. And then your application uses that access token to make requests to protected resources on the user's behalf. So I have a few useful links here to the OAuth working draft, a page on the Google developers page about OAuth and how to use it and everything that it provides and what we support. And then a nice intro from universe.com, which is where I got this great quote here that briefly describes OAuth 2.0. So let's look at that quickly in an example. I want to show the difference between authorization and authentication because I think that might be a little bit unclear. So this example, as it says, is going to retrieve my profile name and photo using the Google Plus API. So I click this Authorized button here. And the first thing it does is pop up a Google. This is accounts.google.com. As you can see, this is a Google login page. So I need to provide my email here and password. And then I sign in. That's the authentication part. That it authenticates me with Google servers only, not your servers. And then the next page it brings me to is the authorization page, where I authorize your application, or the user authorizes your application to make requests on their behalf. So we can see that my app, IO 2012 JS Client Demos, is requesting permission to know who I am on Google, so it can get my profile name and picture. And if I expand that, it tells you a little bit more, associate you with your Google profile. So this segment here comes from those scopes that you pass when you do GAPI authorize. And again, there can be many of these. So the user can click allow access, or nope, no thanks, I'm not interested. Of course, I'm going to click allow access here. And there it goes. It retrieves my name and my little Android figure avatar here. So I've been talking about the API key and client ID a bit. Let's go over what exactly those are. Now, if your application is accessing unprotected resources, then all you need is the API key. And all it does is identify your application is accessing these APIs. And that's important for quota and things like that. However, for protected resources, we need to make sure that you're authorized to access these protected resources. And so that's when you exchange a client ID to our Google authorization servers to get an access token back. And then you pass that access token with each request to access protected resources. So let's go over really quickly where you get those API keys and client IDs. So I'm going to the APIs console here that we saw earlier, and I'm going to create a new project. And when we create the project, the first place it takes us is to the services page, and this is where you turn on all the various APIs that you're interested in. I've been using a few examples, so let's turn those on. I'm going to turn on calendar first. And you can see what it does is it sends me to a terms of service page to make sure I agree to the terms of service first for Google APIs in general. I accept. And then for the calendar API in particular. I'm going to go ahead and agree to those as well. And then we've been using Google+, so let me turn that one on. And again, there's the Google+ terms of service, so I accept that. And finally, we've been using URL shortener as well, so let's turn that one on. And in that case, there is no terms of service for the URL shortener, so we don't see anything there. So now that I've turned on the APIs that I'm interested in, we'll go to the API Access tab. And we can see already under Simple API Access that there is an API key here. Let me just highlight that quickly. This is that key that's sent along with the request you saw earlier, and it will identify your application for unprotected resources. However, if we want to access protected resources, we need an OAuth 2.0 client ID. So let's create one with this blue button here. First thing you do is put in your product name. So when we saw that authorization window, it said IO 2012 JS Client Demos. Let's put that in. And then you can also put a logo, and this will show up on that same page too to identify your application. We're just going to skip that for now. So it asks you what your application type is. And of course, in this case, we're building web applications, so we choose web application. And then down here, it asks for your site or host name. I'm going to expand this to get a few more options here. So this first box, authorized redirect URIs, is not going to apply in our case because we're not doing that kind of authorization. If you go to the Auth 2.0 talk, they'll talk about that a little bit more and what that does. We're just curious about this authorized JavaScript origin because we're making JavaScript requests. So you can see here it's defaulted to www.example.com. Well, this is as a developer, this is the domain that your application is running on. Well, let's just say mine is running on google.com. Now, when verifying these origins, they need to match exactly. So I have the HTTPS protocol here, and that needs to be listed, and then the full domain. And also, if you're going to be using a port, the port should be listed here. So I'm going to go ahead and create this client ID to run my application on secure google.com. And now we have a client ID. So this is what's used to pass to the authorized call to get back an access token so that your application can use that access token to start making requests. Now again, if you're using the JS client, when that access token gets returned, the JS client will save it for you locally, and then whenever you make a request, that access token will automatically be sent. Now if you're sending an access token, you don't also have to send an API key, but it doesn't hurt to, so I generally recommend to always set the API key, and then even if you're using a client ID, the access token will get sent as well, and everything works just fine. Okay, so I'm just going to go over a code snippet here. And again, I included all this code because this is just about everything you need to do to make a nice authorization experience for your application. So I'm going to go through what this does. First, at the top here, we have this global init function, which is going to be executed when the JS client loads. We saw that earlier. First thing I do is I set the API key. Now, I have a variable API key above here that I don't show, but this is the key you saw in the API's console. And then the next thing I'm going to do is call this check auth function here, which is going to make a GAPI auth authorized call. And to that, I pass the client ID that we just created, the scopes that I'm interested in, and we saw we can have calendar maybe, or if you're using the Google+, you want to say that you're going to use the Google+ scope. And then the last value I pass is immediate true. Now what this is going to do is do a behind-the-scenes check to see, hey, has this user already authorized your application? If so, terrific. And if they're signed in, of course, we'll give you back an access token, and you're off and running. Otherwise, you're going to need to send the user through the authorization flow. So when this returns, it's going to call this handle auth result function and pass in an auth result. We need to check that auth result to see first if it exists, and if it does, make sure that there's no error there. And if there is an error, we're going to need to handle that somehow. Otherwise, we get an access token back and we can make API calls. Great. But if we have no auth result or an error, and an error would be this immediate has failed, then we need to send them through the full flow. And to do that, I set this handle auth click method to an on-click handler for an authorized button on the page. Now it's important that you that you have this function kicked off by a user-initiated event, such as a click or a key down, because as we saw earlier, the flow uses a pop-up, and you could trigger pop-up blockers if you try to do it just programmatically. So here's that auth click method down here, and again, I'm calling GAPI auth authorize. Pass the client ID and the same scopes. But this time I say I want the immediate mode false, turn it off. And this will send the user through the pop-up flow that we saw earlier. And then we pass in the same handle auth result because when we do get a response, an auth result, then we know we're good to go and we can go off and running. So one more thing I want to mention is when you get this access token, it expires after a certain amount of time so that you can't use it indefinitely to make spammy applications, for example. Well, it also, when the response has another field in it besides access token called expires in, and this is a value in seconds until this access token expires. So what I've done in this example here is I take that value, it's in seconds again, and I subtract 5 minutes, 5 times 60 seconds, and then convert that to milliseconds so that I can do a set timeout to do the same check auth we saw before, and this does that background check to get your access token so it can happen without interrupting the user while they're using the application. And so by doing it this way, you are ensured that you have a fresh access token all the time. I should also note that this field expires in does not auto-update. So there is a method, GAPI-auth get token, that gets back this token value with the expires in field. Well, that field doesn't update, so don't trust it when you call GAPI-auth set token. Only trust it in this handle auth result callback. So to make an authorized call, like I mentioned, this is done for you automatically by the JS client, but if you're using cores, you need to set this yourself. And the way you do that is you set up one header called authorization, where the value is the string bearer plus the access token. And this is an example access token, which is, of course, long since expired. And that's it. So I've included some links here for you. The first is the home page for the JavaScript client. The second is the discussion forum if you want to ask questions. I'm on the discussion fairly regularly. And then an announcement blog to, the name is wrong there, but this is the link to the announcements blog where I announce various new features for the JS client. And then I also wanted to call out a couple sessions in code labs. There is a code lab for this particular session that I very much encourage you to go to. It will go through all these things that I've talked about in much more detail, and you'll actually build an application using the JS client. You can also go to optimizing your code using features of Google APIs, which is a session on making your APIs access more performant. And finally, a session on OAuth 2.0 and how exactly that works. So thank you very much for coming today. I would like to open up the room for questions if you have them. And if so, please use the microphones so that the folks on video can hear. Thank you.